So I'm going to show you some demonstrations on our worksheet number 4. We're going to start with 1A here. And what you're going to do is use the slope that you see from the center of dilation to each of the points on the figure. So in problem A here, we're going to dilate triangle ABC by a scale factor of 2, and the center of dilation there is C. So what you're going to see is I've got the slope figured out from C to A. I went left 1 up 3, so I do it again, left 1 up 3. And then I'm going to do the same thing from C to B. If I went right 2 up 1, I'm going to go right 2 up 1 again. And that's going to give me my B prime over there. And then finish it off by connecting all our segments, and you can see there that since C was the center of dilation, C is equal to C prime. It did not move. So we've got that one. The next one I'm going to show you is example B there, where we're going to translate, or I'm sorry, not translating, we're dilating triangle DEF, and the center of dilation there is from the point D. So you're going to find that D is equal to D prime. It's not moving. But the slope going from D to F there was left 1 down 2, so I go another left 1 down 2, and then again left 1 down 2, because this time it's a factor of 3. So you can see the line segment there that connects D to F prime there, and that was a scale factor of dilating it 3 times. And so then we're going to go and do the same thing from D to E. If you go right 2 down 2, you're going to go right 2 down 2 again, and right 2 down 2 again, and you get your E prime. And then since D did not move at all, you just finish it off by connecting all your line segments. And there you can see the green triangle there is the dilation by a scale factor of 3. Now over here we're on example 2. I am showing you example A again. This time it's a scale factor of 3, so I'm going to use the slope 3 times from G, because G is the center of dilation, to each one of my points on the figure. And I'm talking about triangle ABC here. So you can see what I've done from G through C. G goes to C, it goes down 2, so go down 2 again, and then go down 2 again. There's your 3 times. And then we're going to go from G to B. So if G to B goes right 3, then go right 3 again, and then go right 3 again. So there's your 3 times. There's 1, 2, 3. And then do the same thing for point A, and it's up 1, left 1, up 1, left 1, up 1, left 1. And you can see what happens there. And so when the center of dilation is inside the shape, you can see that our new image is outside the shape because it was a scale factor greater than 1. It would end up inside if it was, you know, a scale factor that was a fraction. So our next one that we're going to do, that I'm going to show you, is 2C. And we're going to be dilating triangle down here, ABC, from point G, and now it is going to be a scale factor of 1/2. So whatever my slope is from G to each one of those points, A, B, and C, I'm going to use half of that. So let's see, I go from G to A. If I went up 2, left 2, I'm now just going to go up 1, left 1, because I'm cutting that in half. And that's where my A prime is going to be. And then from G to B, if I go down 1 and write, what was that, 7? Then I'm going to go down 1/2 and write 3.5, because cut 1 in half, you get 1/2. Cut 7 in half, you get 3.5. So I go down 1 and to the right 3.5. And that's where B prime will end up. And then from G to C, if it's down, what is that? It went down 6 from G to C, so I'm only going to go down 3 from G to C prime. And then you can see that's where our new triangle, the image, lies inside there, because it was a fraction, it was half. This was a contraction, right? This dilation was a reduction. The previous one was an enlargement. Okay, which example? I'm obviously doing example B here, and look at what's going on there. You're dilating from point H, and you're doing it by a factor of 2, so it is an enlargement. You see how we did that? I just used the slope again from H to each one of my points, D, E, and F. Now I'm going to show you a demonstration for example C. And that one is a dilation of 1/2. So you would expect that to be smaller. It's going to be a contraction. So again, we're going to use half of the slope that we're seeing in there, half the distance from G to each one of those points. So from G to C, and look at how G is outside my figure, so this is what's happening here. From G to C was 2 units down, so I'm only going to go 1 unit down to get C prime. And then from G over to A, it looks like that was maybe 8, right 8, and down 2, so I'm going to go right 4 and down 1 instead. And then let's see what happens from G over to B. Right 4 and down, I don't remember what that was, must have been down 8. Okay, so do you see how that works? There's A prime, B prime, C prime, and it is a reduction, as you would expect, because the scale factor was 1/2. And now we're over on example 4. I'm showing you B. Now it's going to be half the distance, but guess what? Remember when it was a negative scale factor? It just means you go to the opposite side of where that center of dilation point was, so it's on opposite rays. It's the same as rotating this 180 degrees and then also with a reduction in size. So you can see I'm looking at triangle DEF over here, and from H to F, if that goes left 1, 2, 3, 4, then we're going to go to the right just 2, because half of 4 was 2, but I now need to go to the opposite side of H. And then from H to E, if you go up 2 and right 4, instead you're going to go down 1 and left 2. And there's your E prime. Do you understand that? So from H to D, what do? We go up 2, left 2 to get there. So now instead we're going to cut that in half and go down and to the right. So down 1, right 1, and we get that triangle. Okay, and now for D, I'm going to show you. This is not going to change the shape at all. Remember, a dilation of 1, it really keeps the congruence. So it's the same shape. There's no change in size, but because it's a negative, it's going to go to the opposite side. This is going to be the same thing as just simply rotating the figure 180 degrees about the point H. And so that's what you're going to see here. And from H, if it's 1, 2, 3, let's see, 4, I'm going to go 1, 2, 3, 4 down for D prime. And from H over to F, if it's left 2 and up 2, we're going to go down 2 and right 2. And then the same thing from H to E. If you're going right 4 and up 1, you're going to go left 4 and down 1. And you can see that, remember a 180 degree rotation? If you drew line segments from E to E prime, it goes right through H and it's on a straight line together. They're collinear. Same thing from F to F prime goes through H, and D to D prime goes through H. So they're on opposite rays. And now we're on number 5, and we're having to work backwards to find the center of dilation now. And this is actually easier than you may have thought. You just use your straight edge and you're going to draw some lines. You're going to draw some line segments. You're going to go through each point and its image, and then where all of those lines intersect, that's going to be the center of dilation. That point will be the center of dilation. So I'm going to connect lines from C to C prime. I'm going to connect them from A to A prime and B to B prime. And where all of those lines intersect, that's going to be the center of dilation. Now really you only need to do this for two of the images and pre-images, but I'm going to show you through most of these doing all 3. So there's our C and C prime, and there's B and B prime. You can already guess where that point's going to be. And yes, A prime, that line that contains those points, they all intersect right there. I'm going to call that point D since I don't have that in my figure already. And that is at the coordinates -2, 1. And you can see I've written that in the center there. So now, to find the scale factor, what we need to do, and I'm just showing you this again with taking off the other picture right now to clear this up and give us some space. But in order to determine the scale factor, remember from those notes, that pink packet of notes I gave you on Standard 1 for similarity, right triangles, and trigonometry, the very, well, I don't remember what page it was on, but somewhere in there we were talking about finding the scale factor, and it's going to be a ratio, and the way you set it up is what goes in the top of the ratio, the numerator, is a distance from, it's a distance in the new image, and then what goes in the denominator, the bottom of that ratio, is the distance of the pre-image. And so you can pick any one of your points that you want to work with here. I just prefer to choose the ones that are closest to my center of dilation, and also you're going to see if you have points that are collinear with your center of dilation, that's going to be the easiest way to do this. You see how points B and B prime are on the same line with D? So I'm going to use that because that's going to be much easier to calculate the distance. You're going to see what we have to do if none of our points are collinear with the center of dilation. We have to actually form right triangles to do that. But in this case here, I'm choosing DB prime and DB. So as I said a moment ago, you want to set up this ratio. And you notice what I put in the top of my ratio? That's the distance from D to B prime. That's the image. And that was what? Let's see, 1, 2, 3, that's 4. And then what's the distance from the center of dilation to the pre-image? So it's always the image on top and the distance of the pre-image before on the bottom. So that one is a distance of 2, and you can see that reduces to 2. So this whole scale factor in this dilation from ABC to triangle A prime, B prime, C prime, that was a scale factor of 2. And that's how you show it and verify it. So now I'm showing you example B over here, and you can see where the center of dilation is when you connect some of those line segments. You need to pick at least 2, obviously, to do that, but I showed you with 3 again. So the point that I'm calling D, the center of dilation, was at -1, 3. And then now, since A prime and A are collinear with D, they're on the same line, that's going to be the easiest for me to find the distances. So I'm choosing DA prime over DA. Again, it's the image over the pre-image, that length. So we've got 4 there and 8 there. And wouldn't you automatically expect that this scale factor has got to be a fraction? I mean, look at it. From our center, the first thing we see is A prime, B prime, C prime, that triangle. And it's smaller than triangle ABC. So we should automatically be expecting that this is going to be a fraction. And we do want to reduce that. We're not dealing with rules on the coordinate plane right now. We actually have a graph. We're going to go ahead and reduce that scale factor. So I said a moment ago, what happens if you don't have any points on your figure that are collinear with your center point of dilation? And so our next example that I'm going to show you is E, because you're doing homework problems C and D for number 5. And I'm going to show you how we do this, where we form a right triangle. So I could have, in this example that you're seeing right here, on example B, I could have used a right triangle from D to C prime and from D to C. And I could have done the same thing from D to B prime and D to B. Whichever one of those I chose, I would still get the same ratio once I reduced it. Okay, they should have all been 1/2. But the easiest one in that picture was to just do from D to A prime and D to A. So in the next example, I have to use right triangles to show that. So you can see I'm working on example E right there, and I found that the center point of dilation was at the point 3, 2. So I just connected 2 of my line segments there. And you can see that I drew a triangle there from D to B prime. So how am I going to get these lengths? What did we do to get from D to B prime? Didn't we go down 1 and right 1? And yes, I know going down 1 and right 1, that's a slope of -1. I'm not dealing with slope right here. I just want to deal with the lengths, okay? So that was a 1 and a 1. And then using Pythagorean theorem to find the length of that hypotenuse, that's the actual length of DB prime. So in order to do that, it's just the square root of the 2 legs squared, right? That's how you use Pythagorean theorem. So 1 squared plus 1 squared is 2, and I don't want, C squared. I don't want the hypotenuse squared. I want the length of the hypotenuse, so I have to take its square root. So that one is the square root of 2. Now we need to do the same thing from D to B. So if I chose from D to B prime, I've got to use D to B, not some other one now. So to get from D to B, I went down 2 and right 2. And yes, I know it's down, but the length itself, the distance itself is 2. It's positive. So that length from D to B is going to be the square root of 2 squared plus the other 2 squared. So 4 and 4 is 8. And you remember you need to reduce these radicals. You want to look for perfect square factors of that number. And so 8 is the same thing as 4 times 2. So the square root of 8 is the square root of 4 times the square root of 2, which reduces to 2 root 2. So now go ahead and put your ratio together, dB prime over dB. So if we have the square root of 2 over 2 root 2, can you see that the root 2's are going to cancel out? And you're not left with nothing up there, you're left with 1. That was the same thing as 1 times the square root of 2. So this is 1/2. And once again, this dilation is a reduction. So we should expect that that was a fraction. That should have been a fraction. The new image is smaller than the other one that we started with. Okay. What's the next one I'm going to do? Example F. Okay. So there's our center of dilation. 3, 3. And let's see if you can guess at least something about what we should expect with this scale factor. I'm going to write it down near the end, but I want you to look at that and kind of make a guess right now. Is A prime, B prime, C prime bigger or smaller than triangle ABC? And so would that be a reduction or an enlargement? And then look at what's going on with the shapes there. Like, what else is happening there? Are they on the other side of D? And does that look like a rotation? Okay, we'll come back to that. But let's try to find our scale factor. So I'm going to choose randomly here D and C prime and then D and C. I could have chosen DB and DB prime. I could have chosen DA and DA prime, but I just went ahead and picked D and C. So how did I get from D to C prime? So if I go down 2 and left 1, 2, 3, 4, that's really a distances of 4 and 2 there. So to get from C prime over to D, you go right 4 and up 2. And so what will the length of C prime D be, or DC prime? So 4 squared plus 2 squared, got to take the square root of that. So 16 and 4 is 20. And then let's see, what perfect square factors are there of 20? Square root of 20 would be the same thing as the square root of 4 times the square root of 5, which reduces to 2 times the square root of 5. You all remember how to do this, right? From Algebra 1? I hope so. Okay, now we need to make a right triangle for the points from D to C, because I chose DC prime first. It doesn't matter how you draw these, okay? So I'm going this way. If I go up 1 and right 2, so that length over there is 1 and that one is 2. So the length from D to C must be the square root of 1 squared and 2 squared, which is the square root of 5. So remember how to put your ratio together. It's the new image over the pre-image. So DC prime over DC is 2 square root of 5 over the square root of 5. Yes, the square roots of 5 cancel out with each other, and you're left with 2. You said a moment ago that it was an enlargement, right? It looks bigger, so we should have expected something bigger than 1. And now, because it's on the other side, it's really negative 2, right? Negative 2, not just a scale factor 2, but negative 2 because it got rotated. Each point's image lies on an opposite ray from our center of dilation. They're not on the same side, and if they're not on the same side from the center of dilation, then it's going to be negative scale factor. And you can see that it's like you rotated it and then enlarged it, or enlarged it and then rotated it. Either way. Okay, our final one on this worksheet, example G. Look at what I circled there. Why did I circle that? We've got A and then we've got B and B prime, then we've got C and C prime. We don't see an A prime. That means A was A prime. A must be the center of dilation, so no work finding that one. And you know, it's shared. You have two triangles there, A, B, C, and really A prime, B prime, C prime. A is A prime. So you can see the center of dilation is over there at A, which is at the 0.64. So now all we have to do is find the scale factor. And this time we do have points that are in line with A on a straight line together. So it's probably going to be easiest for us to try to find, well, not try, we're going to do it, AC prime and AC. So once again, it's the image length over the pre-image length, and we have 9/6. It's 9 units from A to C prime, and it's 6 units from A to C. We are going to reduce that. That's going to be 3/2. If we are asking you for the scale factor, you should simplify those ratios. We're not dealing with the coordinate plane. Remember the very back page on those pink packet of notes? It was talking about what are you going to do when the center of rotation is not the origin, and you're using rules to figure this out, where you're just going to take the values of the coordinates themselves and do something with the slopes there. That's when you don't want to mess around with the slopes. Well, I'm not manipulating slopes here. I was just using lengths, and so I want the actual scale factor. So it is 3/2. Now let's go ahead and just verify this. Okay, we're going to go ahead and verify this one and make sure that we did it right. Is it really 3/2? Okay, we're going to find that out. So what's the same thing as 3/2? Isn't that 1.5? And yet we're not going to say our scale factor is 1.5. We are going to use it as 3/2. But yes, we know that's 1.5. So if I measured from A to C and that was 6 units away, 1/2 of 6 is 3. And you can see what I've drawn there. So if I go from A to C and that's 6, that represents our 1. And then 1/2 of 6 was 3, so when I go the extra 3, there's my 1/2. So there's 1.5 times there. Do you see that? It was 1, and then 1/2 of that, there's our 1/2. There's our 1.5. That is our ratio. Yes, it's true. It's 3/2. And you would find this same proportion there if you measured the distance with right triangles and Pythagorean theorem like we did before. If you did that for AB prime over AB, you would get that that reduces to 3/2 also. And the same thing, well, there is no A to A prime, so we just have those two, and you could verify it that way. All right, we are finished with this worksheet. You already know the other problems that I just did not do right now are your homework, and I will see you Tuesday.